Okay, we're going to graph sine and cosine. This is our last trig lesson of the year. After this, we're going to do systems of equations. So just stick with me. It's not that hard of a lesson. It's just a little bit different at first. Could be a little bit tricky. If you guys graph a sine function, so this is if you have a function that looks like this, y equals sine of x. You can't really see that. Y equals sine of x, right? If this is a function, whatever you plug into x should get you some sort of value. And the values that it gives you are always going to be between between -1 and 1. So it's going to be in that line and that line. They're always going to go up, down, up, down, up, down. So one thing to note about the graph of sine is that it is a periodic function. That just means that it repeats every set amount of units. So what you see on the screen is one sine wave. So this right here, I'll highlight it. Hold on. This is one sine wave. We call it a cycle. So this is one cycle of sine. And then if you look right below it, notice that we have that same shape just going over and over again, right? That's one cycle. There's another cycle. And then if you go backwards, there's one cycle. And then it's going to keep going forever and ever and ever. And it's just going to make this same wave shape over and over and over again. We call the length of one cycle a period. In this case, the period is 2 pi. The unit here is always going to be in radians on the x-axis. I know we haven't done a lot of radians before, but this is how we graph it. We could graph it in degrees as well, but it makes a little bit more sense graphically to have it in radians. What you guys just need to know is that sine starts at 0, right? That's where the cycle begins. The highest it goes is 1. It's going to go back down to 0, and then the lowest it goes is -1, and then it's going to end back at 0. So it's going to look something like that, right? Those are the key points of this function that we're going to use. And it's going to be very similar for cosine, right? It's probably not going to make a lot of sense right now, but when we do examples, you're going to see it's not so bad. But that's just kind of the gist of a sine function. And if you look at the graph of cosine, notice that it has that same wave pattern. It just starts at a different spot. So if you look at the previous slide, where did we say that sine starts? It starts at 0, right? Where does a cosine look like it starts? At 1, right? It looks like cosine starts at 1. It starts up here. But it's still going to have the same pattern. You're going to go down to 0, and then the lowest it's going to go is -1. And then it's going to go back up to 0, and then you're always going to end right where you started. So it's going to look something like that. And this is what the curve of cosine looks like, right? This is what one cycle is. Just like sine, a period for cosine is 2 pi units, right? So what you see there, what I highlighted, that is one cycle of cosine, but again, it's just going to go forever and ever in both directions. It's going to go something like that. So what I just highlighted is another cycle. And then if you just keep going forever and ever, it's going to have that same exact pattern. So notice that sine and cosine look very similar. It's just they're shifted a little bit. So they have the exact same pattern. They just start at a different part. Some words that I'm going to use today are amplitude and period. What you need to know is that the amplitude is how high or low it goes. So I'm going to write that down. The amplitude is how high or low. How high or low the wave goes. The wave goes. The amplitude is always given by the absolute value of whatever number is in front of sine or cosine. So for instance, if I had let's say y equals -2 sine of x. What is our a value here? Do you see that? -2. What is the absolute value of that? 2, right? So that means your amplitude for that particular function would be 2. What does that mean graphically? It just means the highest it's going to go is 2 units. The lowest it's going to go is -2 units. The negative does something else. It reflects it, but we'll do that when we graph it. The period represents one complete cycle of a sine or cosine function, and it's always going to be given by 2 pi divided by b. B is always the number inside of sine or cosine that's being multiplied with the x. Let me give you an example. If I have y equals cosine of 2x, what is our b value? Our b value is 2, so to find the period, it's going to be 2 pi divided by that number. What is 2 pi divided by 2? Just pi, right? The 2's cancel out. So that means one cosine cycle is pi units. And remember, a cosine starts at the top, goes at the bottom, and then it's going to end back at the top. That is one cycle. This is pi units, right? So that's pi units long. All right, we haven't done an example yet, but when we do, at first it's going to seem a little strange. Just because it's new, that doesn't mean it's hard. Typically, people find this a little bit easier than the law of sine, law of cosine stuff. I know that lesson was kind of a lot. All right, so what I do to graph a sine or cosine function, the first thing you need is to find the amplitude and the period. The next thing you want to do is find 5 key points. There's going to be 5 of them, right? So find the 5 key points. And you're going to multiply by 1/4, 1/2, 3/4. The first number is always going to be 0, and the last one is always going to be the period. These key points you're going to label on the x-axis. And you're going to mark the amplitude, and then you're going to connect the dots that you just drew to get a sine or cosine pattern. Wait. I know it doesn't make a lot of, 5. There's going to be 5 key points that we're going to plot. I know it doesn't make a lot of sense in words, but when we do some examples, the first few might be a little tricky, but then as you do more of them, it's not going to be so bad. So just stick with me for now. Okay, so let's try to graph this function right here. This is 4 sine of 2x. Keep in mind these functions always take the form of y equals a sine of bx or y equals a cosine of bx. The first thing I want to do is find the amplitude. All right, what value here gives us our amplitude? The 4, right? This represents our a value. A is 4. And the absolute value of 4, I'm just going to say this is absolute value of a, which is the absolute value of 4, and the absolute value of 4 is just 4. All right, so that helps us a little bit. In words, I'm going to say that our function goes up and down 4 units. So that's the highest it goes. The highest that it's going to go is 4 units. The lowest that it's going to go is 4 units, or -4 units, I guess, right? The next important piece of information that we need is the period. What value gives us the period here? Right, the 2, right? It's always going to be whatever b, well, not whatever b is, but b is going to help us get our period. What do you need to do with b to get? Oh, I see that. If there's no number, you assume it's 1. Okay. All right. But your period here is always going to be 2 pi divided by b. So you're going to do 2 pi divided by 2, which I think we just did something like that. This is going to be pi. All right. So what does that mean? That just means one cycle is pi units long. All right. The next thing I want to do is find the key points, right? The next thing we want is the 5 key points. This is how I find the 5 key points. I always start at 0, and then I write down a quarter, write down a half, write down 3/4, and then write 1. You guys agree that those are 5 numbers? 0, a quarter, a half, 3/4, and 1. What we do with those numbers is multiply our period by that number. So times pi, times pi, times pi, times pi, and times pi. All right, what does 0 times pi get you? Yeah, right, 0 times anything is just 0. What about pi times 1/4? All right, this very simply just gets you pi over 4, right? You're not going to use a calculator for this one. You're just going to get an exact value. All right, pi times 1/2 is just going to be pi over 2. Pi times 3/4 is going to get you 3 pi over 4. And then 1 times pi is just going to get you pi. So these values you're going to plot on the x-axis. To get a better picture, I like to also get the negative ones as well. 0 is just 0. Another key point that you can plot is going to be negative pi over 4. Another one that you get with this one is going to be negative pi over 2. Another one that you get with this one is going to be negative 3 pi over 4. And then another one that you get with pi is going to be negative pi. It'll make sense why I'm doing that in a second. Just stick with me. So right now, total, we should have 9 values, right? We should have 0, and then the 4 positive and the 4 negative. All right, so these key points are going to help us graph this function. All right, so all we have to do is I'm going to mark that on a graph. The graph is going to be kind of long horizontally, all right? So I would kind of sketch something that looks like this. All right, this is x, this is y. To actually graph the function, I would start at the amplitude, which we said the amplitude is 4. So I'm going to mark 4 on the y-axis, right? It's going to go up 4 units, and then the lowest it's going to go is negative 4 units. All right, and then what you would do is you would mark the key points on your x-axis. 0 is right here. Pi over 4 is right here. Doesn't have to be perfect. Pi over 2 is right here, and you're going to go in increasing order. 3 pi over 4 is right here, and then pi is right here. We can do the exact same thing in the negative direction, so I'm going to say negative pi over 4 is right here. Negative pi over 2 is right here. Negative 3 pi over 4 is right here. And then negative pi is right here. All right, so all we did right now is we just labeled the x-axis and we marked the amplitude on our graph. All right, and then once I have all of that information, we can begin graphing. This is a sine function, right? Do you remember in the previous slides, where does sine start? Does it start at 0 or does it start at the amplitude? It starts at 0, right? So I'm going to plot a point right there at 0. From here, sine is going to go up to the tippity top, right? The very top that it goes at the next quarter mark. That's why we marked the quarter intervals, all right? At the next mark, you're going to take a step down and you're going to go back to 0. At the next quarter mark, you're going to go all the way down. And then at the next quarter mark, you're going to end in the middle again, right? You should always finish where you started. And then what you do from here is you connect the dots. Connect the dots, and then you should get one cycle that looks like that. It's just one big pattern, right? So if you're going up, you're going to keep going up until you're at the top. If you're at the top, you're going to go down until you're all the way down. and then you go back up. It just goes up, down, up, down, up, down. So then to go in the negative direction, I'm going to move this down, and then we go back up. And then at the next quarter mark, you're going to go to the very top. And then at the very end, you're going to end where you started. And then this should be an exact mirror image of what you see on the other side. So just connect the dots, and then it's going to look something like that. All right, and then you can just extend the other sides. Those sides don't have to be perfect, but that's the minimum that I want labeled on the x-axis. Let me zoom out. So it's a little bit of a process, but shouldn't be too bad with practice. The math itself isn't crazy difficult. You don't need a calculator or anything. You're not doing insane computations that you get huge numbers or anything. It's just conceptually, it's a little challenging at first. But again, as with anything in this class, more practice is best. Okay, let's try this one. Just for the sake of today, since you guys haven't seen this before, let's get rid of the negative. Let's just make it a positive. Cosine. All right, so let me just get rid of that. Just pretend it's positive. 2 cosine. All right, we're going to start the exact same process, right? The first thing that I want to find is the amplitude and the period, right? What value gives us our amplitude? A, which is 2, right? And then absolute value of 2 is just 2. All right, how do we get our period? Good, 2 pi over whatever's inside with the x. I don't see a number there. What does that mean? That it's 1, right? 2 pi divided by 1 is just 2 pi. So that means our cycle is complete after 2 pi units. All right, and then from here we can find our key points. These points we're going to label on the x-axis. All right, so our key points, we can start with 0. Whoa, hang on. Yeah, 0, a quarter, a half. We're always going to go in quarterly intervals all the way to 1. All right, what do I do with those numbers now? Multiply them by what? By 2 pi, the period, right? So I'm going to do times 2 pi, times 2 pi, times 2 pi, times 2 pi, and then times 2 pi, all the way down. All right, 0 times 2 pi, what does that get you? It's always going to get you 0. Your first one's always going to be 0. All right, what about a quarter times 2 pi? How do we do that? Okay, it's going to get you 2 pi over 4. Does that simplify? Yeah, 2 and 4, right? It's going to be pi over 2. Nice, right? What about 2 pi times a half? Yeah, right, it's just going to get you pi. You can say 2 pi over 2, which is just going to get you pi. All right, and then if you do 3 over 4 times 2 pi, you should get 6 pi over 4, which that simplifies to 3 pi over 2. And then 1 times 2 pi is just 2 pi. All right, let me make that one look a little better. All right, so we have 5 numbers now that we're going to label on the x-axis. You also want to go in the negative direction just to make sure that you have both sides accounted for. So you're going to take all of your positive ones and you're also going to locate the negative ones. So if I have a pi over 2, we're also going to plot a negative pi over 2. We have a pi, we're also going to plot a negative pi. 3 pi over 2, we're also going to plot a negative 3 pi over 2, and then a 2 pi, we're also going to plot negative 2 pi. All right, so those are 9 points that we want to plot on our graph. All right, that was the challenging part, actually getting those numbers. And then from here, we can just plot them, right? So I'm going to sketch a little graph. Again, it's going to be long, kind of horizontally. So I'm going to say that this is y, this is x. Our amplitude, we said, is 2. So I'm going to make the highest point right here 2, and the lowest point right here negative 2. We also want to plot our key points on the x-axis. We always start at 0. The next number that we had was pi over 2. The next number was pi. the next number was 3 pi over 2, and then the next number is 2 pi. We also had negative numbers. So those negative numbers, we're just going to go in the other direction. It's going to be negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. All right, so our axes are labeled now. All we have to do now is graph it. All right, this is a cosine function. Where does cosine start? Does that start at 0 or does it start somewhere else? Yeah, it's going to start at the highest point. So that's one thing that you have to memorize, guys, is that sine, that wave looks something like that, and it's always going to start at 0. Cosine looks something like that, and it's always going to start, that number is always going to be the amplitude. So it's always going to start at the highest or lowest point. All right, but then once you have that point plotted, your pattern's the same in both graphs. All right, so then if you're starting at the top, where are you going to go from here? You're going to go down to 0, right? And then back down to negative 2, back up to that 0 mark, and then all the way up to 2 pi. All right, and then we get something like that. All right, so that's that side of it. All right, we also want to get the other side, but the pattern's the exact same in both directions. So if you're all the way at the top, if you're going backwards, you're going to go down to negative 2. Wait, hang on. Back up to 0, and then all the way back up to 2. All right, so then when you connect the dots, it should look something like that. And then it's going to go forever and ever in both directions. So something like that. Let me zoom out. And then that's how we graph that function. All right, are we okay with that? Yeah, so let's try this one. Once we're done with this one, I'll save the other two for tomorrow. All right. So let's start with finding the same information. We need an amplitude. What's our amplitude going to be here? All right, -1/2. It's just 1/2. All right, keep in mind it's always absolute value of whatever number's in front. So it's just going to be +1/2. I'll tell you what the negative does, though. The negative is going to reflect your graph. So this negative is going to reflect. Oh, wait, you can't really see that. Hold on. Reflect. Okay. So it's eventually we're going to reflect that, but we're going to do that at the end. All right. What's our period here? Okay, why do you say 1? Okay, so there's nothing in front of the sign. So that number is 1. Does that make the period 1? It just makes it 2 pi, because keep in mind it's going to be 2 pi divided by 1, which is just 2 pi. All right, good. But we're looking at the right places, right? So, good. Now let's find our key points. Again, I'm always going to write from 0 to 1 in quarterly intervals. So 0, 1/4, 1/2, 3/4, and then 1. All right, and then you're going to multiply the period by those numbers. So times 2 pi, times 2 pi, times 2 pi, times 2 pi, times 2 pi. 0 is just going to get you 0. We actually did these numbers in the previous example. So we should get the same thing. So this is going to get you, when you simplify it, pi over 2. This is going to get us pi. This is going to get us a 3 pi over 2, and this is going to get us a 2 pi. Okay, we want the negative ones as well. We want to graph both sides of this function, so this is going to be negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. All right, so we have a bunch of points to plot now. Let me zoom out. All right, and then I'm going to sketch a graph. All right, so y, x. Our amplitude is 2, so I'm going to plot that on the x-axis. Wait, sorry, 1/2. So I'm going to say that that's 1/2, and we can say that this is negative 1/2. Whoa, what did I do? Negative 1/2. All right, and then our key points we can plot on the x-axis. It's going to be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Same exact thing in the negative direction. We have negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. All right, this is a sine function, so where does sine start? It starts at 0, that's where we're gonna go. Typically, we would go where from here? Up, right? But what was different about this one? It had a negative out front. So where do you think we should go now? Down, right? So originally, we would go up, and we would plot a point right there. But since this is a reflection, we're going to go in the opposite direction, and we're going to plot a point there. The pattern is the same, though. It's going to go down, and then it's going to go back up. And then it's going to go all the way up, bless you, and then it's going to go back down. So then when we connect the dots, we should get something that looks like that. If you want to check yourself, the original graph would look something like this, right? Assuming you plotted all your points correctly. Just make sure that when you reflect it, that everything is directly opposite of where it was originally. So in purple is the reflected graph. And then when you're going in the opposite direction, you're going to do the same pattern, right? If you're in the middle, but here it went down, from here you're going to go up, right? You're going to go up to 1/2. So it's going to go up here. And then from there, it's going to go back down. And then all the way back down. And then to the middle. So just connect the dots. So it's going to be something like that. And then it's going to continue in both directions. So you can kind of finish it off something like that. And then that's the graph of our function. So when you zoom out, and then that's the completed. All right, shouldn't be too difficult, just a little tedious at first, but the math shouldn't be crazy challenging. Conceptually, it's a little different, but. Okay, so let's continue. Let's do vertical shifts. Just like any other vertical shifts that you guys learned in this class, if a number is added or subtracted to the function, then you get a vertical shift. So for instance, if you have plus a number, it's going to go up. If you have minus a number, it's going to go down. How I would do these is I would first graph what the original function would look like and then translate the key points that you plotted. So let's do this one as an example, right? Let's start with all the same steps that we did yesterday. So let's start with our amplitude. What's our amplitude in this case? Our amplitude is 1. All right, and then let's find the period. How do we find the period? Okay, 2 pi over what number? All right, it's whatever you see on the inside with the x. So if there's a 4 in front of the x, it's going to be 2 pi over 4. How does that simplify? Good, right? So it's going to be pi over 2. After this, we find our key points. We're going to find positive and negative key points. Yeah, right. So the formula for period is, is going to be 2 pi over b. And b is whatever is on the inside. So sine of b of x. It's whatever number's inside there. Your key points are going to go from 0 to 1. So you're going to do your little quarter marks. You should have 5 numbers. 0, a quarter, a half, 3 quarters, and 1. And then what number are we multiplying to those numbers? The period, right? The entire period. It's going to be pi over 2. So you're not going to have to guess. It's just whatever number you found up here. So times pi over 2 all the way down. Times pi over 2 all the way. 0 times pi over 2 is just going to get you 0. What's 1/4 times pi over 2? It's going to be... Okay, well, how do we multiply fractions? It's not that complicated. So I'm doing 1/4 times pi over 2. If I had like 2/3 times 5 over 7, how would you multiply that? Good, right? 10 over 21, right? You don't need a common denominator at all. When do you need a common denominator? When you're adding and subtracting, right? So all you're doing here, guys, is multiplying straight across. What's 1 times pi? Pi. What's 4 times 2? 8. So we get pi over 8. All right, we'll do the same thing for the next one. What's 1/2 times pi over 2? Pi over 4, right? 2 times 2. And then the next one, 3 times pi is just 3 pi. And then 4 times 2? 8. Good. And then 1 times pi over 2 is just going to get you pi over 2. All right, super easy. Yeah, sign up. These numbers, we want to also include the negative ones as well. I believe on your quiz review, it does say list the 9 key points. So that just means positive and negative, including 0. So for the sake of this class, 0 is always going to be one of them, and then you're going to get the exact same numbers, positive and negative. So those are our 9 key points. We have 0, and then 4 positive, 4 negative. And then from here, we can sketch a graph. So I'm going to I'll try to make it big enough so that you guys can see what's going on. All right, so let's label the amplitude, right? Remember, the amplitude is going to be the vertical distance. So we can mark a 1 and a -1. And then your key points are going to go along your x-axis. So I'm going to make a 0, a pi over 8, a pi over 4, a 3 pi over 8, and then a pi over 2. Exact same points, just in the opposite direction. A negative pi over 2, a negative pi over... Oh, sorry, I did that backwards. A negative pi over 8, negative pi over 4, negative 3 pi over 8, and then a negative pi over 2. All right, this is a sine function. Where does sine start? At 0, right? And then how does that pattern go? Where does it go from here? Up, right? So up here, and then it goes back down to the middle, then down to the bottom, and then back up to the middle. So this is originally what your function would look like. So it's going to be something like that. And you can even do the exact same thing on the other side, right? Go down, up, back up, and then back down. However, what was the difference with this one versus the ones we did yesterday? What does this have? It has a shift, right? How are we going to move this graph that I just wrote in purple? Up 1, right? So every single point that you just plotted, you're going to shift them up 1 unit. So this was at 0. I'm going to move it up to 1. This one is at 1. I'm going to move it up to 2. So I'm going to mark that on the y-axis now, right? I'm going to mark a 2. Oh, wait, you can't really see that. Hold on. Let me use that color. Okay. We're going to mark that up to 1. This one up to 2. It was at 0. It's going to go up to 1. This one at the very bottom was at -1. It's going to move up to that middle point. This one's going to go up to 1. This one's going to go up to 2. All right, so every single point, you're going to move up 1 unit. All right, up 1 unit. So it's going to look something like that now. And then you connect the dots. And it's going to go up here. Wait, what? All right, let me erase that. Oops. All right, so that in the dark purple blue color is how it's gonna go forever and ever, right? So that is our final answer. If you want, you can erase this one on the bottom. Oh, mine's not erasing, but you can erase that one because you don't really need that one anymore. But that was there just to guide you, right? So you really just need that one, that darker color. My screen is glitching, so there's a lot of stray marks. Let me try to get rid of it. Okay. All right, are you okay with that one? Let me zoom out. Okay, and then there's just one more after this one. Let's find the same information. Let's start with the amplitude. What is our amplitude here? 1, right? There's no number in front, so we assume it's a 1. How do we find our period? Okay, so it's going to be 2 pi over, all right, what number is with the x right now? Okay, is it just pi? What else do we see around there? The over 4, right? So you're going to take this entire number and you're going to divide it, or you're going to divide 2 pi by that number. So you're going to do 2 pi divided by pi over 4. That looks a little messy, right? How can we clean that up a bit? Okay, so you can keep change flip, right? So you can keep the first, change division to multiplication, and then flip the bottom. Sorry, 4 over pi. And then so you end up with 2 pi times 4 over pi. The pi's are going to cancel out, and then you get 2 times 4, which is 8. So you get a nice whole number as the period. All right, are we fine with how I got that number? Okay, good, right? So that's maybe a little bit tricky, where some people might mess up. But just be careful. You get a nice number out of it. Now let's find the key points. Again, you're going to multiply by 0, a quarter, a half, 3/4, and 1. And you're going to multiply the period by those numbers. Times 8, times 8, times 8. All right, with a real whole number, it should be pretty easy. 0 times 8 should just get you 0. What's a quarter times 8? Okay, 8 over 4, which gets you just 2, right? 1/2 times 8 would get you 8 over 2, which is what? 4, good. 8 times 3 is 24, divided by 4 should get you 6, and then 1 times 8 is just, yeah, right? They're always going to go up the same amount each time. Good, right? So now let's sketch this out. So I'm going to sketch. I'll mark the points. I'll mark the amplitude. So the amplitude we said is 1. So I'll just mark a 1, mark a -1. And then mark the key points on the x-axis. So 0, 2, 4, 6, and 8. And then same thing in the negative direction. I'm going to go -2, -4, -6, and -8. All right, this is a sine function, so where is this going to start? It's going to start at 0. Let me use a different color. All right, so we'll start at 0. And then it's going to go up, then down, then all the way down, and then back up. So this is originally what it's going to look like. All right, and then the other side you can graph as well. So you're going to go down, back to the middle, all the way up, and then down. So it's going to look something like that. All right, is that our final graph? No, what should we do now? Shift it down 1 unit, right? There is a -1 there. That means you're shifting every point that we just plotted. We're going to move down 1 unit. So I'm going to extend my graph. I'm going to make it go down to -2. Right, it was at -1. Let's move it to -2, right? So then let's move every single point down 1 unit. Every single one of these points, all 9 of them. All right. When you move everything down, it's going to look something like this. These are where the points are going to end up. So something like that, right? And then you can connect the dots. And then it's going to look something like that. And then we know that on either side, it's just going to continue forever and ever. So it's just going to look something like that. And then so in purple is the final function. In orange was just the original. I just shifted every point after that. If you already know where the points are going to shift before graphing it, then you don't have to graph the original. It just helps to be a little bit careful. But otherwise, that's it for this lesson.